Have you ever wondered why a ship that weighs a massive amount floats on water, while small things like pebbles sink? There is a very interesting phenomenon behind these. Let's dive deeper. You might have seen pictures or videos of people floating effortlessly in the Dead Sea. If you think it's easy, try reclining in a similar position in a freshwater pool. Most likely, you will sink. Do you know why? Let us look for the answer in Archimedes' principle. We shall understand this principle through an activity. Here is an object whose volume is 130 cubic centimeter. Weigh this object using a spring balance. Its weight is 10 newtons. Now take a Eureka can. Fill it up with water up to the spout. Under the spout, place a measuring cylinder on a weighing scale. Now gradually dip the object in the water. Observe that the water starts overflowing through the spout, and the reading in the spring balance registers a continuous fall. Once the object is completely immersed in the water, no more water flows out, and the balance shows a steady reading. Note this new reading. It is 8.70 newtons. Hence we can say that the object appears to be lighter inside the water. This weight is called its apparent weight in water. The object appears to have lost 10 minus 8.70, which is equal to 1.30 newtons weight. We have previously learned that this apparent loss in the weight is equal to the buoyant force that acts on the object. The buoyant force is, therefore, 1.30 newtons. Now measure the volume of water collected in the measuring cylinder. It is 130 cubic centimeters, which is equal to the volume of the immersed part of the object. Note the weight of this displaced water. Interestingly, it is also 1.30 newtons, which is equal to the buoyant force. But are these two quantities always equal? Let us confirm by repeating the activity using a different liquid, say glycerine. Note that although the object again displaces 130 cubic centimeters of liquid, this time the weight of the displaced liquid is 1.60 newtons, which is more than before. This is because the density of glycerine is more than that of water. Now, from the spring balance, note the apparent weight in glycerine and calculate the apparent loss in weight. It is 1.60 newtons. Thus, the buoyant force acting on the object this time is 1.60 newtons. Isn't it interesting that in this case too, the buoyant force is equal to the weight of the fluid displaced? This relation was discovered by Archimedes and is called Archimedes' principle. It states that when an object is partially or completely immersed in a fluid, it experiences a buoyant force whose magnitude is equal to the weight of the fluid displaced by the immersed part of the object. Now, weight of the fluid displaced is equal to mass of the fluid displaced into the acceleration due to gravity, which is g. If the density of the fluid is ρ, then buoyant force is equal to volume of the fluid displaced into ρ into g, which is equal to volume of the immersed part of the object into ρ into g. This equation clearly shows that the buoyant force depends only on the volume of the immersed part of the object and the density of the fluid. The same can be confirmed from previous activities. In water, the object experienced a buoyant force of 1.30 newtons, while in glycerine, it was 1.60 newtons. This is because the density of water is less than that of glycerine. Thus we can infer that for the same object, the denser the fluid, the larger is the buoyant force acting on it? Does the buoyant force depend on the density of the object immersed? We can observe and answer by taking another solid object having the same volume of 130 cubic centimeters but at different density and immersing it completely in water. Note that the buoyant force remains the same as before, that is 1.30 newtons. Can you now use Archimedes' principle to understand why it is possible to float effortlessly in the Dead Sea? Due to the presence of a large quantity of salt, density of the Dead Sea water is larger than that for the pool water. Thus, the buoyant force in the Dead Sea is also larger, even larger than your weight. Hence, it pushes you up to the surface and keeps you afloat, while in a swimming pool, you sink. To summarize, when an object is immersed in a fluid, it experiences a buoyant force equal to the weight of the fluid displaced by its immersed part. This is called Archimedes' principle. The buoyant force is equal to the volume of the fluid displaced into rho into g, which is equal to the volume of the immersed part into rho into g. For the same object, the denser the fluid, the larger is the buoyant force acting on it. The buoyant force depends only on the volume of the immersed part of the object and the density of the fluid. Archimedes' principle explains a lot of observations, but how to prove the principle in the first place? Have you ever wondered, what is the proof for Archimedes' principle? Is the proof just experimental, or can we prove it mathematically? Stay tuned to find out.
Keep imbibing. We believe in you.